The question is enthalpy of a system is, तो enthalpy एक सिस्टम का थर्मोडायनेमिक क्वांटिटी है विच इज रिप्रेजेंटेड बाय द टर्म H। अब मैथमेटिकली एक्सप्रेशन में बात करें तो जो H है ये रिप्रेजेंट करता है सम टोटल ऑफ ऑल द इंटरनल एनर्जी ऑफ ए सिस्टम। सो इट इज सम टोटल ऑफ इंटरनल एनर्जी, यानी कि उस सिस्टम की इंटरनल एनर्जी जितनी है विच इज अकर्स ड्यू टू दी कोलिजन बिटवीन द मॉलिक्यूल, रैंडम कोलिजन की वजह से, एंड बाकी जो होगा दैट विल बी द प्रोडक्ट ऑफ पी एंड वी। तो ऐसे हम कह सकते हैं कि जो एच होता है इट इक्वल्स ई दैट इज इंटरनल एनर्जी प्लस प्रोडक्ट ऑफ प्रेशर एंड वॉल्यूम। सो हियर ई रिप्रेजेंट्स द इंटरनल एनर्जी, द पी इट इक्वल्स प्रेशर ऑफ द सिस्टम जिस सिस्टम पर हम काम कर रहे हैं, एंड वी रिप्रेजेंट्स द वॉल्यूम ऑफ द गैस की उस सिस्टम में गैस की वॉल्यूम कितनी है। सो ऑप्शंस में देखिए सबसे पहले दैट इज रिप्रेजेंट्स एनर्जी ऑफ ए रिएक्शन, तो बिल्कुल सही, इट रिप्रेजेंट्स द सम टोटल ऑफ इंटरनल एनर्जी प्लस पीवी, तो अगेन ये हो गया एक फॉर्म ऑफ एनर्जी। ऑप्शन 2 दैट इज टेंडेंसी फॉर लॉस ऑफ एनर्जी, तो कोई सिस्टम कितनी एनर्जी लूज करेगा वो ये फैक्टर डिटरमाइन नहीं करता। टेंडेंसी फॉर रैंडमनेस इट इज रिप्रेजेंटेड बाय अनदर क्वांटिटी विच इज नोन एज एंट्रोपी, तो एंट्रोपी रिप्रेजेंट करती है किसी भी सिस्टम में रैंडमनेस कितनी है, एंड इट इज डिनोटेड बाय द लेटर एस। यूज ऑफ एनर्जी इन ओवरकमिंग एंट्रोपी, तो वो होगी हम कितनी एनर्जी सप्लाई करें उसके लिए, तो ये भी आंसर गलत है। तो इस क्वेश्चन का जो सही आंसर होगा दैट विल बी ऑप्शन ए, एनर्जी ऑफ ए रिएक्शन।
That question is when iron solid is dissolved in aqueous hydrochloric acid in a closed vessel, the work done is, okay, here we have to calculate the work done in the following chemical reaction. When iron react with hydrogen chloride, it will form iron chloride plus H to balance the equation. Here 2, here 6, here 2, here 3. Okay. As we see that here the reaction is occurring in a closed vessel, okay, and we know that in closed vessel, and we know that W equal to work done equal to minus P delta V. Here delta V equal to 0 because reaction is occurring in closed vessel, okay, that delta V equal to 0, so delta W is also equal to 0 here, okay. In a closed vessel the work done will be 0. The reason for the 0 work done is there is no change in volume. So iron is dissolved in aqueous hydrochloric acid in a closed vessel. The work done is 0 here.
Hello, the given question is that Cp minus Cv for an ideal gas is, okay. So here what we have to given is fill in the blanks is given, that is Cp minus Cv is equal to what, okay. So we know that at constant pressure, okay, at constant pressure that is P, the heat given as, that is Qp is equal to nothing but NCp into delta T. Also this value is equal to change in enthalpy, okay. So this value is nothing but change in enthalpy. So you can say that this Qp is equal to nothing but NCp delta T is nothing but delta H, okay. So this is the first equation, that is Qp is equal to NCp delta T is equal to delta H, okay. Now similarly this is at the constant pressure. So now next is at constant volume. At constant volume this Qv, okay, is nothing but NCV into delta T, and this value is equal to change in internal energy, okay. So this value is nothing but change in internal energy, okay. So what we will do, we will equate with this, okay, and this is the value, that is Qv is equal to nothing but NCV delta T, which is nothing but delta U, okay. So this is your second equation, okay. Now Also, we know that the relation between delta H and delta U and delta P is nothing but that is delta H is equal to delta U plus delta PV. Okay, so this is the standard relations. Okay, this is for, let us assume, for 1 mole of a gas. Okay, so this is the relation. What we will do, we will substitute the value of the given data. Okay, also, since this is an ideal gas, okay, since it is ideal gas, so from ideal gas equation we know that that is PV is equal to nRT. Okay? We know that for ideal gas PV is equal to nRT. Okay, and since it is given as for 1 mole, so we will substitute that is value of n, and we will get PV is equal to RT. Okay, now what we will do here, substitute the value of each of the given that is following data, that is delta H. Delta H is nothing but NCP delta C, so here we will substitute. Okay, so delta H is nothing but NCP delta T, and delta U is nothing but NCV delta T plus delta, in place of PV we can substitute RT. Okay, now what will next step is nothing but NCP delta T is equal to NCV delta T. This R is constant, so we take it out, that is outside, that is R, and we will get delta T. Since it is given for 1 mole, so here the value of N will be 1, so here CP delta T is equal to CV delta T plus R delta T. Okay, since delta T is common, so we will get CP is equal to CV plus R. Okay, now the next step is nothing but CP minus CV is equal to R. So that is the final answer. Okay, that is CP minus CV is equal to R. And here what is the filling blanks, that is CP minus CV is what? So CP minus CV is nothing but R. Okay, I hope this answers your question. Thank you. Hello, the given question is that the total energy of 1 mole of an ideal monoatomic gas at 27 degrees Celsius is. Okay, so here we have to find out total energy for 1 mole. Okay, so total energy for 1 mole, total energy for 1 mole, or you can say total energy per mole, is nothing but 3 by 2 into R into T. Okay, so this is the expression for calculating total energy. Okay, so total energy is T dot E, nothing but total energy. Okay, so here what is given, temperature is given, that is 27 degrees Celsius, so we have to convert into Kelvin by adding 273. Okay, so what we will get, 300 Kelvin. This is the temperature, and here the value of R will be 2 calorie Kelvin inverse mole inverse. Okay, we can substitute value of R here, that is 2 calorie Kelvin inverse mole inverse. Okay, now what we will do, we will substitute this given data into the formula, that is total energy for 1 mole will be, for 1 mole will be 3 by 2 into the value of R is nothing but 2 calorie Kelvin inverse mole inverse. Okay, into the temperature is nothing but 300 Kelvin. Okay, so what will happen, for this total energy will be for 1 mole will be 3 by 2 into 300. Okay, so what will happen, this 2 to cancel out and it will become 900. Okay, this will become 900 calorie. Okay, since we are talking about per mole, so here mole inverse and divided by we will per mole, that is mole inverse, we will cancel out, Kelvin inverse and Kelvin will be cancel out, we will left with the only Kelvin. Okay, so the total energy for 1 mole will be what here, that is 900 calorie. Okay, this is a final answer for the given question. Okay, I hope this answers your question. Thank you.